Pain is one of nature's most powerful survival tools. It teaches animals what to avoid. It warns the body when something is wrong. And without it, survival should be impossible. But deep underground, in complete darkness, lives an animal that barely feels pain at all. This is the story of the naked mole rat, and why breaking one of biology's most important rules turned out to be its greatest advantage. A creature that defies mammalian biology. At first glance, the naked mole rat looks like an evolutionary mistake. It has wrinkled, hairless skin, oversized teeth that protrude from its mouth, tiny eyes that barely function, and a body adapted not for speed or strength, but for squeezing through narrow underground tunnels. Nothing about it suggests success. And yet, naked mole rats have built one of the most extreme survival systems in the animal kingdom. They live almost entirely underground in vast tunnel networks, often stretching for miles. These tunnels are hot, crowded, low in oxygen, and filled with carbon dioxide, conditions that would quickly kill most mammals. But naked mole rats don't just survive there, they flourish, living where pain becomes a liability. In the underground world of a naked mole rat, pain is not always helpful. Their tunnels are packed tightly with other colony members. The air is filled with high levels of carbon dioxide. The soil contains acidic compounds. Friction, scratches, and chemical irritation are constant. For most mammals, this environment would trigger nonstop pain responses, burning sensations, inflammation, and stress. For naked mole rats, those signals are muted. They lack normal responses to certain types of pain, particularly pain caused by acid and capsaicin, the compound that makes chili peppers burn. Even exposure to acidic conditions that would cause intense discomfort in other animals barely affects them. How the naked mole rat rewrote pain. Pain signals in mammals are transmitted through specialized nerve pathways. In naked mole rats, some of these pathways are altered or missing. Specifically, they lack a neurotransmitter called substance P in certain pain-sensing neurons. Without it, pain signals from acidic or irritating environments simply don't reach the brain in the same way. The result is extraordinary. They can live in high CO2 environments without experiencing the burning sensation that would force other animals to flee. They can move through abrasive tunnels without constant distress. Their bodies remain calm in conditions that would overwhelm most nervous systems. In evolutionary terms, this is critical. Pain normally forces animals to change behavior. But in this environment, reacting to every painful stimulus would be inefficient and dangerous. Reduced pain perception allows naked mole rats to function where others cannot. Survival in low oxygen pain resistance is only one part of the story. Naked mole rats are also astonishingly tolerant of low oxygen levels. In their crowded burrows, oxygen can drop to levels that would cause brain damage or death in other mammals. When oxygen becomes scarce, naked mole rats don't panic. Instead, their metabolism shifts. They can temporarily switch to a form of anaerobic metabolism, similar to plants, using fructose instead of glucose to fuel their cells. This allows their brains and hearts to keep functioning even when oxygen is dangerously low. This ability buys them time. A society built underground, pain resistance and oxygen tolerance supports something even more unusual. Naked mole rat society. They live in large colonies, sometimes numbering over 300 individuals. This makes them one of the very few eusocial mammals, comparable to ants or bees. Within the colony, roles are divided. Workers dig tunnels and gather food. Soldiers defend the burrow, and a single breeding female, the queen, reproduces while others do not. This lifestyle depends on tolerance, crowding, friction, constant physical contact. These would cause stress and injury in most mammals. Reduced pain sensitivity helps prevent chronic inflammation and aggressive reactions that could destabilize the colony. In other words, pain resistance supports cooperation, when pain is less important than endurance. Pain is a warning system, but it comes at a cost. Responding to pain requires energy. Stress responses elevate heart rate, suppress immunity, and drain resources. In an environment where threats are constant but non-lethal, reacting strongly to pain becomes inefficient. The naked mole rat made a different trade-off. By dulling certain pain pathways, it conserved energy. That energy could be redirected toward digging, foraging, reproduction, and colony defense. Pain didn't disappear entirely. It became selective. Critical injuries still register. Life-threatening damage still matters. but minor irritations no longer dominate behavior. This selective sensitivity is one of the most refined survival strategies in mammals. The unexpected benefits of pain resistance. As scientists studied naked mole rats, they began noticing something else. These animals live far longer than expected for their size, often 30 years or more. They also show remarkable resistance to cancer, maintaining stable cells where mutations would normally cause tumors. While pain resistance is not the direct cause, it is part of a broader pattern, a body optimized for stability over speed. Their cells repair damage efficiently, their metabolism runs slowly, their stress responses are muted. Together, these traits create an animal that ages differently from almost every other mammal. Cancer resistance and cellular stability. As scientists continued studying naked mole rats, their strange relationship with pain led to an even more shocking discovery. These animals almost never get cancer. For a mammal their size, this is nearly unheard of. Most small mammals age quickly and are highly susceptible to cancer. Naked mole rats, by contrast, can live 3 decades with little sign of decline and without the tumors that plague other species. The secret lies in how their cells behave. Naked mole rat cells are exceptionally good at detecting overcrowding. When cells begin to pack too tightly, a common trigger for cancerous growth, their bodies shut down further division almost immediately. This process, known as early contact inhibition, acts as a powerful brake on uncontrolled cell growth. Their cells also produce unique forms of hyaluronic acid, a substance that helps maintain tissue integrity and elasticity. In naked mole rats, this compound is longer and denser than in other mammals, providing both physical protection and additional cancer resistance. This biology mirrors the animal's broader survival strategy: stability over speed, control over reaction. The trade-offs of feeling less pain. Despite its advantages, reduced pain sensitivity is not universally beneficial. Pain, when properly calibrated, prevents dangerous behavior. It forces rest after injury. It discourages reckless movement. It signals when something is seriously wrong. Naked mole rats did not eliminate pain entirely. They refined it. Severe injuries still register. Life-threatening damage still triggers protective responses. What changed is how their bodies handle constant, low-level irritation. This refinement only works because of their environment. In open ecosystems filled with predators and sharp terrain, dulled pain would be disastrous. But underground, where threats are slow, predictable, and environmental rather than sudden, pain resistance becomes an asset. This highlights an important lesson of evolution. There are no universally good traits, only traits that fit a specific context. Why evolution took this path? Evolution does not aim for perfection, it aims for sufficiency. In the naked mole rat's case, the underground environment applied unique pressures. Low oxygen, constant physical irritation, limited resources, and high population density. It reduced pain where pain was counterproductive. It enhanced tolerance where tolerance mattered. It prioritized endurance over reaction. The result is a mammal that feels less pain, not because it is weak, but because it is perfectly adapted. Rethinking pain as a survival tool. Pain is often framed as essential, but the naked mole rat forces us to reconsider that assumption. Pain is useful when it provides actionable information. It becomes harmful when it overwhelms the system. By muting certain signals, naked mole rats remain calm in environments that would induce panic in other animals. That calm translates into efficiency, energy conservation, and long-term survival. They don't ignore danger, they ignore noise. The naked mole rat proves that sometimes the greatest advantage isn't strength, speed, or even intelligence. It's knowing which signals to ignore.